Hello everyone. We are going to discuss data structures and simple understanding of graph data structures. So today I will cover very few like a very simple way so that everybody will understand. So our session focus on recapturing or new entry level programmers who want to learn that. Okay, so let's get started. So the topic is about graphs specific to inside the data structures. Okay, what is graphs? Graphs in data structures are non-linear structures consisting of vertices, what is also called as nodes, and edges. Okay, edges that connect these vertices. Okay, edges representing relationships between the data points, and these edges offers the a versatile way to model real world scenarios. Let us see some of them. Various types of graph data structures. Directed graph.
Edges have a direction indicating a one-way relationship between vertices.
Undirected graph.
Edges have no direction representing a two-way relationship.
Weighted graph.
Edges have associated weights or costs.
Cyclic graph.
Contains cycles, meaning there's a path that starts and ends at the same vertex.
Acyclic graph.
Does not contain any cycles.
Complete graph.
Every vertex is connected to every other vertex.
Connected graph.
There is a path between every pair of vertices.
Disconnected graph.
Consists of multiple connected components.
Bipartite graph.
Vertices can be divided into two sets such that no two vertices within the same set are connected.
Planar graph.
Can be drawn on a plane without any edges crossing.
Yeah, these are some of the graphs I try to cover in describing them. So we will try to do a sample code with very few of them. We will not do every type of them. So let us go for a next step. Representation of graphs, adjacency matrix and adjacency list. So there are two ways to represent these graphs in code. Okay, adjacency matrix, a 2D array where element at matrix ij indicates whether there is an edge between vertex I and vertex j, and the other representation is adjacency list, an array of lists where each list array of I stores all the vertices adjacent to vertex I. Okay, now let us see traversal algorithms for a graph.
There are two common graph traversal algorithms. Breadth first search BFS explores the level by level using a queue to manage the order of visitation. Depth first search DFS explores as far as possible along each branch before backtracking using a stack or recursion.
Thank you. So these BFS and DFS are very similar to trees. So whatever we do, the same thing do for a trees, we do the same thing for graphs as well. So even in trees, breadth first search and depth first search, the same way we do in trees, the same way we'll do in graphs as well. Let's go for next section. Graphs applications.
Application of graphs. Social networks representing users and their connections. Maps and navigation. Modeling locations and routes. Internet representing web pages and hyperlinks. Circuit analysis, modeling electrical components and their connections. Task scheduling, representing dependencies between task recommendation systems, suggesting related items based on user preferences.
Yeah, so these are the real world scenarios we try to cover, our applications where we use graphs, we try to represent in the slide. But so in let us see here, social networks, one is connected to other person, so the relation between those two people, and like the A is connected to B and B is connected to 10 people, and each next level persons connected to, let us say B is connected to C is connected to D, E, F, and D, E, F again connected to A. So which means there is a cycle here. So anyone can connect to anyone, which means that kind of design can be representing using graphs. And between connections also, there is a one directional connection or two-way connection, so that is also possible. And in maps also, in flight, when you are traveling, when you are taking a flight, so one node to another node, for example Delhi to Bangalore, there can be various ways you can travel from Delhi to Bangalore, and you can land in between two or three places, or you can directly go from Delhi to Bangalore. And there is a way, this is one directional, and there can be multiple paths also, like that. So maps also can be represented using graph application. That is one of the graph application. Okay, so let us see. Thank you for joining us.
If you like this video, give it a thumbs up. Subscribe for more Python plus data structure and algorithms. And do let me know in the comments if you have any questions on these real-time code examples. Thank you. Like, share, subscribe, comment, and let's talk in the description. Thank you.